Alright, so in the last two videos we looked at just graphing quadratic inequalities. So now we're going to take it a step farther, and instead of having a y and then is greater than, less than, and so on with our quadratic, we're going to actually solve. And you have to remember, back when we were solving quadratic equations where they had an equal sign, we always had to have it equal to 0. So we were finding the roots, the x-intercepts. So now we're going to do the same kind of thing, but with an inequality. So we're going to look at a couple different methods. We're going to start with the most, I would say the most tedious and probably least efficient way, and work our way up to what can potentially be the most effective way. Okay, so let's start with the least efficient. So we're going to start with making sure that the inequality is greater than or less than 0. Remember, in order to solve, has to be a 0 on the other side. So then we're just going to pick some values for x to plug in and evaluate to see what makes this inequality, or the one that we have, true. Okay, so when it's true, that gives us our range for what our possible solutions are. So for the first one we have in the example, x squared plus x is less than or equal to 6. So if I subtract the 6 over, that'll give me 0. And then I'm going to pick these, I just chose x values to plug in, and we're going to see what ones make this true and which ones don't. Okay, so again, you can see why this is tedious, because I have to just keep plugging in the x values. So if I plug in -5, I have -5 squared plus -5 minus 6. Okay, and I want to know what the y value is, but ultimately, is it smaller than or equal to 0? So I'm going to get 25 minus 5 minus 6, which gives me, 25 minus 5 is 20, minus 6 is 14. So that is not less than or equal to 0. If I plug in -4, I get -4 squared is 16, minus 4 minus 6, so that gives me a value of 6. So we're getting closer, but still not smaller than 0. If I plug in -3, I get 9 minus 3 is 6, minus 6 is 0. That is less than or equal to 0. So this is the first one that works. This one doesn't, this one doesn't. Okay, so that means -3 is my starting, my boundary for where my solutions are. Okay, let's look at -2. If I plug in -2, I get 4 plus -2 is 2, minus 6 gives me -4, right? 4 minus 2 is 2, minus 6 is -4. Another one that works. Okay, if I plug in -1, I get 1, minus 1 is 0, minus 6 is -6. We're still working. If I plug in 0, I get out -6 again. Notice these two would be mirrored points. They have the same y value. So that means the vertex for this particular one, if I were to try to find it, happens between 0 and -1. That's just a little side note. Okay, so we're still working. It's still all good. So now if I go to +1, I get 1 squared is 1, plus 1 is 2, minus 6 is -4. Notice again, we've got a mirrored point. The vertex happens halfway between mirrored points. Okay, and then if I plug in 2, that one works. If I plug in 2, I get out 0. And that will be the last one that works, because it has to be less than or equal to 0. So when I plug in 3 and get out 6, this one doesn't work. So I would write my solutions as follows. Okay, this is in the inequality form. If you remember when we did interval notation, I would use a bracket because it's equal or equal to, starting with -3, and then again a bracket ending at 2. So either of these would suffice if you're not sure. All right, let's look at one more using this method. So again, I need this to have a 0 on this side, so I'm going to subtract the 3 over so that I have 2x squared plus 2x minus 3 is less than or equal to 0. Make that squared a little nicer there. Okay, so I'm just going to use the same x values, and part of the thing that makes this even less efficient is, you know, I don't really know if these are the best points to choose, because you notice I kind of approached down to where the vertex would be and then worked my way back up. If this range that I just used doesn't have the vertex in it, I might not see what my solutions are going to be for this inequality. So this method really just is very cumbersome, but at least it lets us see numerically that which x values satisfy the inequality itself. So for part B, if I plug in -5, I'm going to have 2 times -5 squared is 25, plus 2 times -5 is -10, and then minus 3. Okay, so let's see, so I've got 50 plus 10, or minus 10, excuse me, is 40 minus 3. So I get 37, not less than 0, so this one's out. If I plug in -4 using the same process, I got out 25. If I plug in -3, I got out 9. If I plug in -2, I got out 1. If I plug in -1, I got out -3. So this area, this is somewhere between -2 and -1 is where my cutoff starts. Now it's less than or equal to 0, so I'm not sure where between -2 and -1 it is, and that's again where this gets a little bit cumbersome. -1 definitely works, but I'm all the way at -3. Where does 0 happen? I'm not really sure. Okay, if I plug in 0, I get out -3 again. Okay, if I plug in 1, I got out 1, which doesn't work. So somewhere between 0 and 1 is my cutoff for the end, and somewhere between -2 and -1 is where it starts. So this method is kind of yucky and doesn't really work. So we're going to look at another method here using the graph to help us. Again, it's not the most efficient, but it does work. So let's look at the next process. Okay, so we're going to actually graph these. Okay, we're going to graph them as if they say y is less than or equal to or greater than or equal to and so on.